Hi everyone, welcome to this new episode of Entry Life. Today, I have Christine join us to tell us a little bit more about the custom resource metric, right?
Yeah, hi, thanks for having me. I'm Christian. I work at VMware and at the community, I'm mostly active in the cluster API space. And today here to talk a little bit about kube-state-metrics and custom resources, I think, right?
Yeah. Okay, that's awesome. And for those who watch our show for the first time, we have like a YouTube channel, and you can find our previous episode there. And they're all about like Kubernetes, networking, or like tons of product and the awesome things we have here at VMware. So if you are interested in our channel, please consider subscribing it. Okay, great. Let's jump into today's content.
Yeah. The title of today is Custom Resources in kube-state-metrics. Maybe we should first talk about what custom resources and kube-state-metrics is, right?
Yeah.
So, so a short introduction for custom resources. Basically, they are some kind of extension to the Kubernetes API, mostly known as some resources like in cluster API, for example, you have some machine deployments or cluster objects you deploy to Kubernetes, and custom controls use them to, for example, in this case, provision a cluster or something like that. Similar to what Kubernetes is doing with its normal resources like pods or deployments. So now also kube-state-metrics, what is that? Kube-state-metrics is there to expose this information you have in your resources, like mostly known for exposing metrics for your pods or deployments or something like that. It's the current state you normally see you also see using kubectl, but by using the kube-state-metrics, you can store the information in some kind of database, and you will be able to query the data on later times and also we will be able to create some alerts if something is wrong with the state, right?
Yeah. So it can be used on the existing Kubernetes resources as well as the customer resources, right?
Yeah, exactly. Basically, it was written for the core resources of Kubernetes. So there are
Okay.
lots of metrics like for pods, for deployments, for replica sets, for stateful sets, and so on.
Yeah.
Yeah. So yeah. So how do you consume kube-state-metrics? May be also interesting. Basically, kube-state-metrics only exposes its information by an HTTP endpoint. And you actually consume it using Prometheus later on. So Prometheus is, in this case, the database which takes a look at kube-state-metrics in an interval like 30 seconds or every minute, and grabs the current state and stores it into its database. So if you take a look at Prometheus here, that's like a Prometheus I've got running here in my local system, and I'm able to query all the data which is stored in there. And if we take a look at what's there, there are lots of metrics which have the prefix kube, which are mostly exposed by kube-state-metrics in this case, like for daemon sets. There's a metric when a daemon set was created. So yeah, basically that's the idea of kube-state-metrics. Yeah.
Okay, so here we want to filter all the so here we go through all the resources and look at this like parameters in each resources, right?
Yeah, here we can query all the metrics, kube-state-metrics or other information Prometheus gets from other applications, and query the data and take a look at it, and also have graphs and take a look at it over time, and So, for example, if you have a deployment and at the next day you see, yeah, something was broken tonight, you maybe can use the metrics to get a kind of an idea what happened. Like you could maybe see that the pod was restarted or something like that.
Yeah, it looks great if we have like a graph here.
Yeah. Yeah, so it's pretty well known, I think, in the Kubernetes space to use kube-state-metrics to have additional alerts on top of Kubernetes for cluster operations. Yeah, and so maybe to get to the exciting new stuff kube-state-metrics provides. As I said, kube-state-metrics provides lots of information or lots of metrics for the core Kubernetes resources. And since the latest release of kube-state-metrics, or the latest 2 minor releases, it's also possible to have some custom configuration file for kube-state-metrics to also expose metrics for your custom resources, which kube-state-metrics has no idea of, right?
Mm-hmm.
Yeah. So what could it be used for? Like, if you think of cluster API, you have resources which describe your cluster and the state of your cluster. And by using a custom configuration, you can also have metrics for these resources. Maybe I can show some example here, right? If I go to the shell, I have here some development cluster API running, and I can use kubectl to actually get the cluster resource, for example. And there I can see I have 3 cluster objects here. And for example, one information which is provided by kubectl directly is the version field, like which version is my cluster running at. If I take a look at a single object, there's lots of more information in here, like some condition informations, or yeah, the phase the cluster is currently in. Like in this case, it's in a provisioned phase. Yeah. Also, there's some other information like the numbers of replicas it should have for the workers or for the control plane nodes. And this is all information which may be useful to have in a metric system and maybe to write alerts, right?
Yeah, right. It provides a very flexible way to define what metrics we want to track and have a easy way to set up the alert for them.
Yeah. So maybe to take a look at how this works. I know we now know we have here some kind of cluster resources, and if I take a look at the observability namespace here and at the pods which are running, I can see I have here Prometheus running and also kube-state-metrics. And on top, there's also Grafana, which could be used to create dashboards, but we'll take a look into that shortly, I think. So we have here Prometheus running, and as I did already show a quick view at the UI here, but yeah, maybe how does Prometheus know that there is kube-state-metrics and that I have to gather the information from there? Maybe that's would be interesting too. So
yeah, right, exactly. How do they know? Like, there's
yeah. So basically, like for lots of applications, there's configuration for Prometheus, and you can do some big static configuration here and do lots of kind of things like in scrape configs you can define to a reference to some HTTP endpoint, and Prometheus will continuously grab the data from this HTTP endpoint. Specifying all this kind of endpoints could get horrible if you have lots of applications running in Kubernetes, and that's why Prometheus also provides some auto discovery to detect where are some applications running where I can grab metrics from. Like in our case, what the interesting one would be kube-state metrics, but there are also metrics which come from directly from the Cube API server or other applications which get created. So when taking a look at the configuration page for Prometheus, there are lots of different configuration possibilities where Prometheus could do some service discovery. And in our case, we use the Kubernetes service discovery, which then takes a look at which services we have in our case and tries to find an annotation at the service object. And by that, it knows, okay, this service is a service I have to take a look at for metrics. We can also take a look at how it is done in our case for kube-state-metrics, right? So if we take a look at the service of observability, there are some services like also kube-state-metrics. And if we take a further look at it, look at service kube-state-metrics. And if we take a look at it, there's some interesting annotation here, which is called Prometheus scrape true. So the service discovery sees this annotation and then knows, okay, I have to scrape the service because someone set this annotation. And that's one way how service discovery in Kubernetes could work using Prometheus.
So this annotation here means that if I set this value to true, Prometheus, so this object is visible to Prometheus. But if I set it to false, it can it's not visible to the Prometheus. Is that correct?
Exactly. But if it does not exist, or if it's set to false, or some other value, Prometheus, the service discovery of Prometheus will say, okay, that's not something for me. I don't have to take a look at it. But by setting it to true here, it knows, okay, I just take whatever is defined here in ports and also add the /metrics path to the URL and to gather all the metrics. And maybe we could show how this request looks like. We can do it on our own, right? It's just an HTTP endpoint. So we could take a look how kube-state-metrics exposes all the metrics, right?
Yeah, right. Curious about how the HTTP path looks like.
Yeah. Maybe some background on that. There's something called the Open Metrics specification, which is a big specification which came from or some way together with the Prometheus project, which defines the way how this is done. So that's a kind of a standard way to expose metrics for, in this case, for example, Prometheus. So if we do a port forward on the kube-state-metrics service, or directly onto the pod, port 8080, then we can use curl to actually take a look at what Prometheus would see. So Prometheus does the same, but using, of course, the internal IP. We are now doing a port forward to access the HTTP server directly on my notebook here. So let's add -s so we don't get some garbage output. And there we can see there's it's a plain text format following a specific way how it should look like. And for example, there for every metric we have some kind of type and some help information, so we can we know that this is a Gauge metric here, and the type is followed by the name of the actual metric, and same for the help information. And for example, the cube certificate signing requests label has this kind of help information. Yeah, and so there's the type and help information, for example, and there are also entries with having data. Like, for example, here we have a custom metric called KP cluster info, which is of a type gauge. And the entry for the metric looks like this. It's the name of the metric, and in curly braces, there's some labeling information. You can think of it like being some text information, a key value pair. And at the end, there's also a value for it. So in this case, the metric has the value of 1, but it could also be 0 or any other kind of floating point value. Like, we could expose by that the creation timestamp, the Unix timestamp of the creation of something, or have a counter like how many requests I had or something like that. That's that's the value of a metric. And of course, there's also interesting information in the labels. Like here, for example, there's some kind of IP exposed, or the name of the object the metric is for, or the namespace of the object the metric is for, or one interesting here is, for example, there's also the version referenced here. I just don't see the whole output, I think, but yeah, some cutted string here, but actually that's the version of the cluster exposed here, which is also interesting. Now I got it.
Yeah, so I think not all the information about the cluster shows up here, right? So it looks like we select a few metrics that we want to see, but like where we define what we want to shows up here.
Yeah, exactly. For all the cube entries here, the information which is exposed is hard-coded into kube-state-metrics. So that's Go code, which defines what is exposed here. For metrics which have the prefix copy, in this case, all this information comes from what I did define in my configuration file for my cluster API cluster metrics, in this case. So as we can see, there's some kind of topology version here, and maybe I can do again the kubectl get clusters request, and we can see here this entry maps to the second entry here, which also shows here the same. It shows exactly the version which is shown here, or you can see in kubectl get -o YAML. There's somewhere in the YAML there's this information, and you can also see the name of the object here. And in this case, the namespace is not shown because of the kubectl output, but basically that maps one-to-one to the metric here. Yes, you can think of kube-state-metrics does the same as we do when we do kubectl get to the object. Oh, sorry for that. Kubectl get cluster -o YAML, and expose information we defined as labels here. And if we take a look here, there's somewhere in the YAML output, there's this version information which gets exposed by kube-state-metrics. So
Yeah, it looks great.
Maybe we're now at the point where I did show some configured metric. What do you think? Would it be good to also show the configuration for it?
Can you show the configuration for where we define which metrics we want to show for each cluster?
Yeah. So let's just take a look at maybe this metric here. I have a big configuration file because there are lots of metrics I want to expose for my custom resource definition. So this is a pretty big file. I collapsed some parts here, so there you can see I have some additional entries here. But maybe to take just a look at the cluster object for now. So this is the configuration file for the kube-state-metrics. This is not a thing which I do kubectl apply currently to the cluster. This is a file which is stored in a config map, and kube-state-metrics reads that config map and reads that in that configuration from here. And yeah.
Got it.
By use
Yeah. Please go on. Sorry.
Yeah. So there's this kind of resources array where I can define different kind of API resources to, or normally custom resources to expose metrics for. So you can have one entry for each group version kind, pair, or key. And in this case, we have the cluster, we refer to the cluster CRD of the group cluster xkates.io in the version v1 beta 1. We can also see it's the same when doing kubectl get here. It's also the same here. Let me scroll a bit up. So this maps exactly to the API version and kind we get using kubectl in this case. So this tells kube-state-metrics to get the information from the API endpoint provided by the Kube API server for this resource.
So we're not defining the metrics for each specific cluster. Instead, we define the metrics we want to track for each kind of resources.
Yeah, exactly. Basically, you have your custom resource definition, and for your custom resource definition, you will expose metrics for all objects which are of that kind. Yeah. So in our case, we have 3 clusters, and for every metric, we will have entries for each of the 3 clusters.
Mm-hmm. Yeah.
Yeah. If you later on want to filter to a special cluster, you can use the Prometheus query language to do that. Like, and maybe can show that quickly. So we are seeing the shell output, but I can also just filter here for the KP cluster info metric and also see 3 entries for each of our clusters. And the query language, I don't want to explain the whole language for now, but I can filter for labels here, for example. I want to filter for all clusters which have this version set, for example. And when I query for that, it will only show me the ones which have this version label set. So that's how you can later on filter for things like, I'm only interested in the objects in the default namespace, and I can filter for namespace equals to default, for example. Let me just do that. Namespace equals default. And it now shows me all 3 because all of them are in the default namespace.
Yeah. Yeah, that's great to know that we still have some way to look at the information of one specific cluster.
Yeah, and maybe if we take a look into the information which is provided, there's, for example, here the name field, the namespace field, and the UID of the object. And these 3 labels are defined in my configuration. So if I switch back to that, there's here some configuration for labels from path, like the name label comes from the path of the object at metadata name, or the namespace label is the value of metadata namespace, or same for the UID. It's just a JSON path inside the object in this case. Yeah.
So that line 10, line 13, and line 16 define the name of this metric, and the rest are the path to find this metric, right?
Yeah, exactly. This one defines the key in the metric, and what follows here is from where the value comes from.
Yeah,
So
yeah, that's
I could
clear.
also I could also call this cluster name, and the key would be always cluster name, for example.
Yeah, yeah, that makes sense.
Yeah, and maybe to get to the info metric, so this here are labels which are set for every metric I create here. So these are values. As you can see, I'm using the metadata information here, and I don't want to repeat that for every metric I create. I always want to have the name, the namespace, and the UID at the metrics. So I would be able to distinct between the value of the one cluster and the value of the other cluster. And then I can define special metrics or different metrics which, yeah, have different configurations below that. Like the first metric I did create was um, this info metric. It's getting combined using this prefix here, so it's kp underscore cluster underscore info, just like we did see in the Prometheus
Yeah.
um, query. So if we take a look back here, that's exactly the same here. It's the prefix and an underscore and then the name of the metric.
Oh, I see. That's where this name comes from. Yeah, I was a little bit confused about like it looks like some label that defined by ourselves, but I didn't really know that where it comes from.
Yeah, this is all configurable and you can name your labels however you want. In this case, we try to follow the examples or the samples we have from the implementation of kube-state-metrics. Like the objects of cluster API have some same or similar information, and you can compare objects to core resources. Like machine deployments are pretty similar to deployments, or kube bottom control plane is maybe more similar to a stateful set or something like that. And we try to follow the convention defined in the open metrics specification, and by following the examples of kube-state-metrics of the already integrated metrics to create our configuration for cluster API.
Okay.
Yeah. So now maybe to get to the other values, like we have here the info metric, and below here we can define also additional labels for the info metric. Like here we define the topology version field, which one-to-one maps to the key here. So here I add the topology version key value pair to my metric, and the topology version key value pair gets its value from the .spec topology version field of the object.
Yeah.
And similar here for the others.
Okay.
Yeah.
So,
That's
mhm.
yeah, go ahead.
So the name, namespace, and UID defined above is shared by all the metrics, and here the name info is some additional metrics that's specific to this information about a cluster.
Exactly. Here in metrics, I can define multiple different metrics having different key value pairs or different values, but all of them will have this information, which is the same.
Yeah, I see.
Yeah, like every cluster object has a metadata.name field, and I want every metric of my cluster objects to have this name label then in Prometheus.
Yeah, that makes sense.
Yeah. So this info metric is pretty straightforward. It will always have the value of 1. Maybe why is that? for that, we can take a look at the open metrics specification. And open metrics specification defines different kind of metrics and what their value should be and how some naming scheme should be done. And if you take a look at the types of metrics, there's also an info metric here. So so that's the whole description what an info metric is. And an info metric basically always has a value of 1 and just exposes information in key value pairs at the labels. So yeah, in this case we have this info metric, and the value for every cluster, as we can see here, is 1. And yeah, we have some information here we can use for building dashboards or something like that. Yeah. Before I come to other kind of metrics, like, for example, replicas, I may show how this could be used to create dashboards. So I have prepared some small dashboards using Grafana here, and we did take a look a lot at the version field for now. And for example, I can build this kind of dashboard where I can see which versions are all my clusters at, in this case. Yeah, that's one use case, for example, for the info metric to display this information. Yeah. If I take a look at the query for that, I just use the copy cluster info metric here and have some additional syntax from PromQL to just count how many have the same topology version information and display that in the diagram here.
Yeah. I'm still a little bit confused about, so if we go back to the Prometheus page, and what that the number at the end of each line, what that means? So,
this here?
yeah, right. What does that mean?
Yeah, this is a value for the metric, and for info metrics, this value is specified to always be 1. Because for the info metric, we only want to expose information here in the middle at the labels, like some key value pairs. So maybe a better example where you can see that this information, the value at the end is not always 1 is if you take a look at the KP cluster created metric, and we can see it's another value, and in this case it's the creation timestamp of the cluster object. For example, that's the Unix timestamp of the creation of the object.
Yeah, but so when we define the metrics in this KP cluster created, we not only want to show the timestamp, but also some other informations about that, right? So that's why we have the string value here as well as a number here.
Yeah, like we defined to always have the name here again, that comes from the top, the namespace, and the UID of the object.
Yeah.
That's the part we defined. The additional key value pairs here, for example, they come all from Prometheus in this case, or from the service discovery of Prometheus. So we can use this information, for example, to see, okay, this matrix comes from kube-state-metrics.
So is it possible? Is it possible that the number at the end of each line is a list instead of a single number? So for example, if I want to know that who created this cluster, there may be a user ID, something like that. So is it possible that there are 2 values shows both user ID and timestamp at the end of each line?
And the value can only be 1 value, but in that case you can expose multiple metrics for your single cluster object. Like so you would have one entry which has the one value and another entry which has the second value.
Okay. Yeah.
And
that's something we can do.
Yeah, and also you can add some label here to still be able to know this is the first this is the first value and the other one is the second value, for example.
Yeah, that also works as well.
Yeah, maybe to get to the other use cases, I've also defined a metric which is called KP cluster status phase to take a look at in which phase is my cluster. And if we query for that, we get multiple outputs here, not only 3, but multiple. I know a cluster is always in one state. And for this metric, for each cluster, only one entry will be of value 1. So if I filter for that, I get back to only 3 entries. And I can see there's some kind of phase here, which shows me, okay, that one is in the provisioned phase. This is another type of metric defined in the open metric specification. Maybe I first go back to what the definition says here. This is called a state set. And the state set, is a collection of strings and related to Boolean values in this case. And only if the Boolean value is 1, the value will be 1. And in our case, maybe I go back where this value comes from. So in this case, we take another look at the kubectl output, at clusters, and we see here that's the phase field. If we take a look at the YAML here, you can see here in status, that's the phase field, and that's where this information comes from. And now what's making this a state set is the status phase of a cluster is always one of a list of well-defined strings. In this case, it's, for example, provisioned. It could also be unknown. And we want to know in which phase my cluster is at. And by that, we expose multiple entries for my cluster object, but only the entry for provisioned will have the value 1.
Okay, so we have a list of available value for this parameters, and if this cluster is in a specific stage, we will have that value equals to 1, and all the others should be 0.
Yeah, exactly. Maybe it's getting better when we show the configuration here. So this is the definition of this status phase metric, and it gets its value from the status phase field, like I did show, where currently it states provisioned.
Yeah.
And as addition, we provide a list of strings the value could be. So it could be pending, provisioning, provisioned, deleting, failed, or unknown. And
this is type state set.
Yeah, and this is the state set type in this case, yeah. And kube-state-metrics will get our cluster and expose a metric for each of this list for my cluster. So and only one of them will have the value of 1. We know our cluster is in provisioned, so the value for the provisioned would be 1, and for the others the value would be 0. I can also show that now on the Prometheus UI maybe, but when we query we should see this 6 metric entries for my cluster, and the value should be 0 for all except for the provisioned entry.
Okay, got it. Yeah, it's very clear.
So maybe show that shortly. When let's filter for a single cluster, and we should see that there should be 6 entries. So here we've got the 6 entries, and here at the phase label we have the different values of the list. And if we go through that, only the one with phase provisioned has the value 1. And that's how such a state set metric comes alive. Yeah. And now we started, I think, at the not very obvious metrics. So maybe to get to the most intuitive one, there's also this kind of gauge metric, which just exposes a value like the number of replicas my deployment has set, or the number of replicas my machine deployment has set. So if I take a look at another metric, which is called KP machine deployment, spec replicas, you can see in this case we have machine deployments which have their value set to 3 of so maybe to highlight here, we're now not looking to the cluster object anymore. We're taking a look at the machine deployment object. I can show that on the kubectl side too. So if I do kubectl get machine deployment, you see here we have 3 machine deployments, and all of them have a value of 3 in that case. So that's the gauge metric. I can just expose the number which is given there, which is also, which is a very interesting feature. Like I can use the numbers here, for example, to show, okay, if I take a look at this machine deployment here, I can see there's no ready replica, and I can use that information or show that information using Prometheus and have alerts or have a dashboard which shows me that.
Yeah, that would be very useful, I think.
Yeah, maybe to take a look at that machine deployment shortly at the YAML output. We see, so the spec replicas metric uses this information in spec replicas. And there are also other integers which get exposed, which are at the end here in the status field, which is very similar to what a deployment does. And there we have, for example, again, a status replicas field, which shows the current state. So in spec, you say, I want 3 replicas. And in status, you see, okay, currently there are really 3 replicas existing. And there's also the information, okay, I have 3 unavailable replicas. And there's also a metric for this unavailable replicas field. And by using that, I can, for example, write an alert if the unavailable replicas field is too low for a too long time. I can, get paged and fix that.
Yeah, that's very useful for alert, right?
Maybe I show the unavailable replicas metric here too. It's called KP machine deployment status replicas unavailable. I more or less showed the JSON path here in the metric name too, so it's more human readable. And as we can see here, we have 3 machine deployments, and one of them has 3 unavailable replicas, and the others seem to be fine in their current state. Yeah, and for such metrics, it's interesting to have some kind of a graph, and we can see here, okay, there are 3 which are unavailable, and if they get ready at some time, the metric will drop to 0, and we could see the historical information for that. Maybe we also take a short look at the configuration for that one. What do you think?
Sorry, what?
So I will also show the configuration for that one. So here again, we have the group definition. We use machine deployments, have some kind of namespace UID we always want to add. And then here we can see there's the spec replicas field, and we just say, okay, this is a Gauge metric, and please just set the value to whatever there's set at spec replicas, which will be 3 in our case.
Yeah. It's like another example, right, for this kube-state metric.
Exactly.
That looks great. And also I'm a little bit like curious about like how this kube-state metric get all this information from the cluster.
Yeah. So basically, kube-state-metrics does use client Go, like kubectl would do, and it opens watches to the API server to always have the current information. So it will, use the watches and update its cache with the information it needs to have. And by this configuration, we tell kube-state-metrics to also cache this information for us and make it available at the HTTP endpoint for Prometheus then.
So this kube-state metric is in between of the Prometheus and the cluster.
Yeah.
And
maybe we can show some picture here. Like this is an overview from the Prometheus page, and we have Prometheus here in the middle. And Prometheus does get its metrics from something called exporters, like the targets. And one of them could be kube-state-metrics. So it pulls its metrics from kube-state-metrics here. It stores them in its database and makes it available by the HTTP interface or by its API. And I think I also got a picture about the relation of kube-state-metrics to the API server. Like in our case, we have, as I did show, the namespace observability, where we have the pod kube-state-metrics. I did also show for service discovery, we have the service for kube-state-metrics. And what kube-state-metrics does is, to gather its information, it talks to the API server of Kubernetes and tries to pull all the time the information from the API server, just like we would do a kubectl get all the time and store this information. So it's using the API server to get the information, and then Prometheus will then go ahead and try to pull the information from the HTTP endpoint and store it in its database.
yeah. So if the kube-state metric keep pulling informations from the API server, well, will it like be is it possible that there's like too many requests to the API server that cause the performance issue?
Yes, sure. It's doing the same like any other request to the API server or watches. It tries to be very efficient in doing that by using watches. So it only gets updates to the objects. But yes, for sure, it's doing requests and load to the API server to do so.
Okay.
There's configuration for kube-state-metrics where you can say, okay, I'm only interested in this metric, not in everything kube-state-metrics does. And by that, you can scope down kube-state-metrics to the things you really need if it's creating too much load. And also for very big clusters, kube-state-metrics offers configuration to spread or scale out kube-state-metrics horizontally to have multiple kube-state-metrics pods, and they only, or each kube-state-metrics pods would then only scrape apart, like the one would only scrape for the cluster objects and provide that metrics. The other kube-state-metrics pod would only provide the information for the machine deployments or something like that. There's lots of things to configure here, and that should be all documented here at the documentation. If we take a look at the CLI arguments, there are lots of options to optimize here. Like in this case, I was talking about the sharding, which is the scale out thing. Or you can also limit kube-state-metrics to take a look only at a specific namespace, or have a deny list of namespaces it should not take a look at.
Yeah, that seems reasonable.
And by the way, these here are the two interesting new flags which could be used for the custom resource configuration. So if you want to provide your configuration, you could either use one of these flags to provide it to kube-state-metrics.
Yeah, that's great to see.
Yeah. There's also some further documentation of the feature, which also explains again how it could get consumed, and also has some examples how to use it. I think that's also helpful for anyone who wants to start and use that. And maybe for ideas what it could be used for, it could be used for any kind of custom resource metric, as I said. Like one use case would be, for example, if I have a backup tool like Velero, and the Velero custom resource shows me the state of my backup, I can use kube-state-metrics to have metrics for my backup information, and then have alerts if my backup fails, something like that, to get notified.
Okay. Would you like to share this link? So I can send that to the chat.
Maybe some other way how to consume it. As I said, cluster API. I did use cluster API as an example, and there's some documentation how to use the latest state of cluster API, and this could also be used to just run the example config I have running here. It's integrated in the tilt environment for cluster API. So yeah, if anyone wants to take a look how it's done there, there's some documentation how to enable kube-state-metrics in there. And also the configuration for cluster API is stored in the repository, so we could also link that. CRD. CRD config file, which contains all the config I just did open for to present. So that may be also an interesting resource if someone wants to take a look at.
Yeah, those are very useful information about that.
So it could look like, yeah.
So we talk about like all kinds of like metrics we can set up. So is there like any dashboard we can take a look at how they put together, how they look when they put together?
There are currently no published dashboard anywhere. I just have some examples around here at my local environment. What will be there in future maybe are some alert definitions for Prometheus. There was a current Slack thread about that. to provide some default alerts for cluster API, which build on top of the metrics. They should be visible then in here. Like here, for example, I've got one alert configured for the metrics I did create, which is an alert which triggers when there are paused objects. So in cluster API, there's a configuration in the object, like you can say, okay, I want to pause all operations on my cluster, and if you set that, this alert would trigger if this is for too long. So soon in the cluster API examples, there will be more of them, or they will be there in the cluster API repo, for example. We have to take a look how we do it with some example dashboards. These are some first dashboards I tried to create, like one which takes a look at a special cluster. For example, it shows the creation timestamp, or the Kubernetes version, or the number of non-ready nodes here. But they're published nowhere currently.
Okay, so what's the relationship between these Grafana things and the Prometheus? So does Grafana gather data from the Prometheus, or it get information from the kube-state-metric?
Yes, Grafana does query to Prometheus to get the information. So,
okay.
For example, for this graph here, it uses this query, and I can take that query and just execute the same here, which shows me the same information, just not as a pie chart here in this case.
Okay, so
Grafana is configured to query to Prometheus here. We have Prometheus here selected as data source, and just gathers the information from Prometheus and displays it here.
Okay, got it.
So maybe if we go back to the picture here, as you can see here, there's the Prometheus Web UI or Grafana or any other clients which use the Prometheus to query the data.
Yeah, that's very clear. Okay. So we have only like 2 minutes left. So like, is there like anything you want to add?
Maybe just to add, in Cluster API, we will do some more things. We will try to generate the configuration, because as I did show, it's a big YAML file I had to manually write, but we try to actually be able to generate the configuration from code, like have some comments in the definition of the custom resource and use that information to generate the YAML file. Because there are lots of providers in Cluster API, and they all may want to expose metrics too for their resources, and of course for others too.
Yeah, if we can have the automation for that, that would be like very helpful, because it make it much easier for the developers, right? They just need to add an annotation in their code, and then all the configurations will be generated from there.
Yeah, if someone wants to follow that work, I pasted the link in for the GitHub issue for that. Yeah.
Okay. Let me copy it here. Awesome. Okay. Thanks, Chris. Before we end, is there a question from our audience? Okay. So thanks, Christine, for joining us today. And it's like I have a very clear whole picture about like how we like use this kube-state-metrics to get information from cluster and do the parameters on the top to like query the information and finally shows up in the Grafana Grafana dashboard. So thank you very much for providing all this information for us today.
Yeah, thank you for having me, and I hope people start using the feature in kube-state-metrics.
Yeah. So, and if you have any questions, feel free to reach out to us, and I'm sure that Christine will be very glad to help you with all of the problems or questions you may have when you try this feature. Okay. Thanks everyone for watching. See you next Wednesday.
Bye.
Bye.